Actually, guys, my assumption in here is that you already have this program that you can contacted me already, or someone shared this program to you already from my source. It's a huge program already to me to discuss one by one, and the reason why I'm saying that is that I'm not going to describe one by one again. But if you are new to this videos in this thread, you can go back and start all over from the very first episode of the Arduino-mMm project. You gotta watch all these videos and explain a little bit in details of the instruction from the small programs. In here, I put many comments on here trying to explain it. And I can actually explain that in a block diagram instead of the program instruction in here at the Arduino IDE. So let me open my presentation, and the Arduino is my presentation, and then switch that into the Arduino project. And I'm talking about the subroutines right now by your story. This is the HMI amplifier panel project under the DR100W concept project. So let me go dive to that. So this is my program too, and start again with the variables declaration and declare which microcontroller is being used as a control to the external hardwares, and then you get the setup. You set up your microcontroller, the input output, whether this is an input or an output, and you have to initialize them. And then this is where the subroutine coming in, the active mode subroutine, wherein you're going to power the amplifier and then turn on LED one, and then scanning the SW1. That's the function of the active mode subroutine. And then it says that the next subroutine is going to standby mode, which is another subroutine that will be called or invoked into the program. And the function right now is just turn off the LED one. And then you get your main program, which is the main function right now is that it will going to scan this SW1 if someone press it. So how the program works is that it starts with the variable declaration, and then it goes to the setup. After the setup executed, it is keep active mode subroutine and going standby. After setup, it jump to the main program. So the main program actually is invoke and just scan the SW1. And inside here, the SW1, the program will call the active mode subroutine, and after that the active mode subroutine will going to call the going standby mode subroutine. That's how the program logic flows. And if I'm going to go to the next slides, oh, that is just a capture of the subroutine. um, it's not so clear, but if you're going to the block diagram in here, once the DC power is applied to the Arduino, it will go to the void setup and go to the void loop. And then it will go directly to the main program, what I just mentioned. And basically, the start of the main program is in the standby mode, which means the amplifier is closed and the LED is off, as you can see in here. And then it watch SW1 for depress. Currently no one depress it, and the program is keep running in here. It says that if SW1 is pressed, it says no, and it keep running in here, running. And if the user press SW1 says yes, it goes to the subroutine active mode. The amplifier is on, like when I press it in here, and the LED is on, and now it is watching SW1. So it says that something's wrong with my program. It should be goes this way. Let me delete that one. Should be the right way. Sorry for that. So we are now in the subroutine active and the power. Let me So the subroutine, we are now in the subroutine active mode, and it is in here, and it's watching this SW1 right now, which is LED one is lighted, and now it's watching SW1. The program is watching SW1, and if it is no, it just keep running in the active mode subroutine. So keep running, running, running like this. And if the user want to close the power amplifier, all you have to do is to press the SW1 again. I press it, and then was SW1 depressed? And the answer is yes, and it goes to this direction. It goes to the subroutine power down. It will turn off the LED as we can see in here, and then it will go now to the standby mode. So that's how it works. It keep running in the main program called the active mode subroutine, in the active mode subroutine called the power down mode subroutine, and then going back into the standby mode. That's how the logic of the program works, which is currently working right now. Well, guys, what do you think of my logic? Is that make sense? Or do you have some other logic that probably much better, or another way to see how the power on and power off an amplifier? It's really crazy that we wanted to change this toggle switch here, toggle up, power on, and nothing to do already, no challenges. And then toggle off, toggle down, no problem. Know anything about the UART communication, programming, Arduino, then life is simpler. But this is not really what I wanted to do. Challenges makes me think. So let's go to the Arduino code. I'm gonna start defining the microcontroller in here. We have been discussing that in the previous videos, and also the void setup in here. Uh-huh. Start with the curly block in here, the starting curly block and the ending, and we can have here our subroutine. So these are sub programs that I'm trying to dissect the program, not in the what we call it the whole program, which is difficult to manage. So I put a subroutine in here, which is I discussed earlier. Another subroutine here is the power down standby, which is when you power off the amplifier, it it goes to this subroutine and it will going to do the necessary the power down mode sequence. Well, I view the program as a large program that I'm incorporating, like the volume control, the relays, the thermostat, as well as the DHT11. So when you're going to power off later the power amplifier, it execute several sequence of the external peripherals. So I put that way so that when you power down the amplifier or close the amplifier, it just simply means to say that it goes to different a sequence of powering off this kind of peripheral external hardware, like for example this volume control in here, this DHT11. Okay, the DHT11, this is one here, this is the thermostat, and that's the reason why I put it this way. That's my logic. Maybe you can find a different way to execute when you power off your power amplifier later. And let's be particular about those in related to the serial communication. Let me see that one. So in here, the major thing that you're going to declare is the serial communication baud rate. So it starts with the serial begin, and the 9600 is the one that I'm comfortable to use it. This is in bit per second, and that's it. I think I have the explanation in here. And if you see this program later, you can have a fully loaded explanation. Try to explain what is all this instruction we're going to do. And those in a blue one, like for example, these Arduino projects preceded by both quotation, it's going to use the serial print line. This is serial print line, which is going to display this in the terminal log. Let me put that to open again the terminal log, and let's see if I'm going to make it working. So I just opened the terminal log, and you can see that I'm doing a project waiting monitor. So what you write in the program is exactly what you can get from the terminal log. So I'm doing a project, there is the I'm doing a project in there, and using terminal monitor for viewing the status of the LED one and switch one, which is also the same as the one that you that the Arduino is outputting right now to your computer. So whatever you write in here, it is in the setup. This is in the setup, and it will write this terminal information into your serial monitors. The trick in here is that you need to understand where you're going to put this information, so that you'll be knowing where is exactly the block where the program is executing it right now. So in case of this, it is executing in the void setup. These subroutines in here, they will not be executed in the normal execution of the program. So after the void setup is executed, and this one will display, it will jump immediately to the void loop, which is the main program. And you can see in here, it is now watching the SW1. Currently, no one is pressing it right now, so the LED is in the off state. And the program says that if someone is not pressing it, and this end of the program in here will going back to the void loop. No one pressing it. It's just like circling over there, but it is watching if someone will press SW1. And if someone press SW1, it will go to this if statement in here that just want to check if the switch 0 is really a 0 logic or less than 1, which is still at the ground level. And it says that you will go to the active mode. So now you are calling the subroutine to perform its function. So the active mode subroutine is in here. Where is the active mode? So these are the subroutine, and it is in the active mode. So let me press the switch now in the standby mode and press it. Now it goes into the active mode. Now the terminal log says that someone pressed the key, and now the A3CS in the active mode, and the LED is lighted. It is lighted in here. And let's go back to the active mode subroutine. So this is the active mode subroutine. This is the one that will light up the LED. And then these are the terminal log information. And then the next one is that it's now watching the switch. So the whole instruction in here, it is now watching the switch if someone will going to press it in the active mode. As the terminal log in here, it says while in the active mode, let me see if someone press SW1, this one in here. And what I wrote in the active mode is that it's the same, this one in here. While in the active mode, let me see if someone press SW1. So what I wrote in here in this block is actually the one that is being output in the terminal log. And it says that if no one is pressing the key, it will just keep looping in here from here. Keep looping in here. And then if someone press SW1, it will go to power down standby. So this is again another subroutine that it calls inside the active mode, and it will perform the function of turning off the LED. So if I'm going to press it right now, assuming that the amplifier is turned on and the LED is turned on, press it, and it will go into the standby mode right now. The terminal log says that um, Yes, indeed, someone press SW1 and now the LED is turned off and I'm now in the standby mode. So LED is turned off and now it's in the standby mode. So it actually execute the power down standby. So this is the one that I wrote in there. Turn off the LED. This is the one that turn off the LED with a digital right power LED low. Why it is low once again? So that it will goes to logic 0 or 0 volt and the LED will turn off. 0 volt means LED is turned off. Plus 5 volt means LED is turned on. Plus 5 volt is logic 1 or logic high, and then it goes for an execution, and after that this power down standby will go back to the active mode, and it will exit and going back to the main program. So that's how the main program works. It calls the active mode, and in the active mode will just be there watching the SW1 again if someone press it, and if someone press it, it calls the subroutine power down standby, and then it will going to turn off the LED, and after that it will going back to the active mode, and the active mode will going back to the main program. That's how the subroutine calls in the program. Well guys, are you following me so far what I'm trying to impart in here in this demonstration and tutorial? If yes, that signal me to end this video. Otherwise, if not, let me know on the comment below what is lacking. Is it I'm over emphasizing or overreacting, or what? Whatever you think of my tutorial right now, let me know on the comment below. And I think that's the end of this video, and I hope you like it and subscribe to my tutorial right now, the Arduino project HMI power amplifier front panel. And from the comfort of my apartment here in my job site here in mainland China. Bye for now and see you in the next video. Don't miss that guys, don't miss it.